Okay, so let's look at the other type of variation. We already saw how we would plot a discontinuous variation on a graph. Let's look at continuous variation now. Okay, so this time we're looking at the mass. So again, something that's measurable, something with definitely intermediate groups, and then the number of players, rugby players, who are within each of those mass, the mass range. So first thing is we want to make sure we create ranges. So this is a little different. We're not going to go and like plot every single individual player and how many and like what their weight is. That's going to make this graph super messy, right? We want to statistically look at this data. So the first thing is we want to make these ranges. There's going to be a video in the assignment lab the lab assignment that you're going to do. You have to make sure you watch it to really know how to do this after watching this video. Okay, so I'm going to make a range of, let's say, 70 to 79, then 80 to 89, 90 to 99, etc. You notice the numbers do not overlap. You're not going to have 70 to 80 and then 80 to 89, because if there's one individual, a couple of individuals who are 80 kilograms in weight, how would you know which range to place them in? Okay, after you do that, you're going to tally up the numbers and place them in each of those ranges. So when I say tally, what I mean is this. Here you have, let's say one individual is 75 kilograms. You're going to tally it up by having that one there. Let's say, and in this case, there's 3 individuals in the 80 to 89 range. So you're going to tally it up by going 1, 2, 3. Again, the video that's in the assignment handout will really show you how to do this in a nice way to illustrate it, because you're going to have to do it yourself. Here we've got 4, so 1, 2, 3, 4. 5, you guys do something where you probably put a little line in the middle, like the fence, and then 2. Okay, so you tally it up, and then you put those numbers there, and then you go to plot it. Same as before, figure out which one's the independent variable and place it in the right place. In this case, it's the mass in the x-axis, and then figure out what's the dependent variable and place it in the y-axis. Don't forget, again, we're going to do all these things again. So make sure the headings are there, the correct scale is in there. Remember, the ranges go in here. So again, 70 to 79. You can write it like this, or you can write it the way they have it here, 80 to 89. That's fine too. However you write it, look at all the different examples I give you, and you figure out which one you want to use, and then you go and plot it. So there's one individual who's 70 to 70 in the 70 to 79 range, 3 in the next range, and so on. Sometimes people refer to the ranges, they use the word buckets instead. That is fine as well. Okay, so the bucket of 70, 79, bucket 80 to 89. Okay, this is a little different. You notice there's no spaces in between, not like a bar graph. So technically this isn't a bar graph. It's called a histogram, and there's no spaces in between the bars. When you're done that, it's going to look something like a bell curve. So you want to be able to talk about the trends. Let's say there was one more individual who falls under the 120 to 130 range. You have a nice little bell curve. Okay, all right, so this particular variation, when we plot it, is a continuous variation. Let's see why, right? First thing is, there's a range of phenotypes from 2 extremes, right? Light to heavy. If we're talking about someone's hand length, right? Really, really small hands to really, really big hands, right? Most people fall in the average, which is why there's a bell curve, because most individuals are on the average range of that particular continuous variation. It's caused by genes, right? Someone's weight is caused by genes, but it's also influenced by the environment, right? What's your caloric intake? How much food, calories are you taking in each day? The phenotypes can be measured. You can measure someone's weight. You can measure someone's hand length, right? And again, I gave you some examples there. All right, so again, this is called a histogram, and it is an example, a type of bar graph, but it is called a histogram. All right, this is another example of it. It's being illustrated here, looking at a height category. This must be for kids who are primary schoolers, because it's quite short. Like, I would fall in this category. Would you say, Ms. Fan, is average height for a woman? Probably not. If this was like what we would use as adult females in America or Canada, I'm probably more like at the end here. Okay. You can't make that pen work, so we'll just ignore it. All right, so this is an example of that. All right, you are going to go and do a lab assignment soon. Please make sure you read all the instructions carefully and you do this correctly, okay? And you book a Zoom meeting or ask me questions if you're not sure how to do this. All right, that is everything. Bye, guys.